So basically, you guys want to know how to set up the simulation to do whatever questions you guys want. So, um, how about we do this for an example? So, which one of you guys wants me to set up a custom pool? Something like that. And I'll do it on the recording.
Yeah. Uh, I suggest that yes, we can do it. Is a good idea. But really, just to start really from scratch. So something like we have something like an empty cat template, and then go step by step as you said in Discord. Use this JSON file to initialize your pool and so on.
Okay.
Or what is
Well, let me think about that because the driving process for the CAD model
yeah.
is a bit based on the actions.json. So if I don't have external price updates coming in there, nothing's really going to happen. Boost talking?
Mhm. Yeah, you are right. My sentiment is because I'm a beginner in Balancer. For me, I observe a balance pool, something like microeconomy. Okay, firstly, in principle, it is something like a closed economy. Okay, so I just would like to start with a pool that is closed, that has no interfaces to the outside world.
All right. No interface to the outside world. We can do that.
Because actually, my research objective is going to be make a sensitivity analysis on the initial parameters. You know, uh, play with weights, transaction fees, and things like that. So very, very simple for me.
Okay.
So if the others also agree with that, that we can start at least with something very, very simple. And I think we will have also the opportunity in the next call to discuss a little bit more advanced cases. But you can also tell me what you think about it.
Well, I'm up for that. Does anyone else? Nomi, you look like you want to say something?
Yeah, I was just going to say so. I mean, as I understand it, the model and what you've set up is essentially does a call to get some real historical data and then feeds it through a sort of replication of the balance protocol, um, like a digital twin. So I don't know, So I was thinking, you set it up. Maybe you can set it up with different parameters as Vasilius wants, but then you still have to feed in the real data, right? Um,
Yes.
can you
Well,
do that? Yeah.
getting the real data is a pool and project specific process. So I'm afraid if it's about getting the pool specific historical data, then probably won't be able to demonstrate that successfully today. But I can show you how to do like the initial setup parameters and all that. And
Yeah.
then,
Yeah.
yeah, okay, cool. So now I have here, I am in my balancer model. I am on the ARB agent weight change branch, which is why I have notebook 3 here. And let's say I want to make a new pool. I'll just copy this thing. And wait, let me just do that in the terminal. Okay, so I made something called demo pool. Can you guys see? Is it big enough?
A little bit bigger could be better if possible.
How do I make it bigger? Damn it. Ah, something like that. Wow.
Yeah, that's better. Yeah, that's cool.
Okay, so I have opened my demo pool initial pool states prices.
Mm-hmm.
So here, let's see, I don't know what tokens you guys want. Vasi token.
Doesn't matter. Yeah.
Then we have Jizu token. Then we have, I mean, sushi nomi is kind of like sushi already, right? And then Kierchi. So we have these tokens. Let's say that the weight, or if you want to do weight changing, then it is best, it is safest to have all the weight changes, to have all the denorm weights add up to something that is less than 50. Because of some quirk in the Balancer V1 code. In Balancer V2, this should be fixed, but they haven't even implemented weight changing yet, so we're not talking about that. So, do you guys want weight changing or not?
Let's keep it simple with no weight
let's keep
changes.
it very simple.
Yeah.
So let's say everything is 10. So we have a 25 weighting of all the 4 tokens in here. And so Vasi is 1,000, Jesus has 2,000, Sushi has 3,000, and Kirti has 4,000 tokens. Bound simply means that that it is enabled within the pool. So you can have tokens that are disabled within the pool. Don't really know how that works yet. So the generated fees is actually a sort of, it changes with every time step, and it's only for that particular time step, so it's not cumulatively generated. Then later on in post-processing, you sum this all up to get the fees generated per token. So let's say you want a swap fee of 1.5%.
Mm-hmm.
Yeah. Okay, and this pool was created on this time, and the token prices.
One question: the pool shares is something that you have to define, or is by default?
You can set this to you can define this yourself. Yes.
Okay.
Okay, so these are the external prices of your tokens. And we shall hop on over to the, I guess, actions. Oh, yeah. This is the actions. Okay, so I'm just going to copy this because I don't really feel like it's going to work if I don't use an actions.json, because the actions.json, each line within here is basically the driving force for the each step of the simulation. If there's no more lines here, then the simulation stops. That's it. Okay, so we go here, we do that, and I think that Aave was Vasi, and I think that SNX was Jesu, and I think that Wi-Fi is Kirti. Okay, so I save this and I close this. Now I open up Jupyter Notebook. Great. And now I will try and share a different window. To share a different window. Right, I want to share this window. Alright, you guys see this one?
Mm-hmm.
Oh, whoops. I'm in the wrong directory. Let me get out of here. Let me create a different... Yeah, okay, and great, now I have to share a different window. I have to share this window. Crap. Move to new window. And stop sharing this one. Now I share that one. Okay. Yes, so right, so now you can see I made a new NB demo. I'm going to go into it and I'm going to adapt it to use our demo JSONs. Wow, is it supposed to be this slow? What's going on there? Oh, there we go. Okay. So here we can change this. This is just for cosmetic purposes. What we want to do is we want to make sure that the external US currency is USD or USDT. I think in this case, if we look back at the actions.json, the external price was denoted in USDT, so you need to put a USDT here. We do not want weight changing. We also are not going to do any arbitrage, actually. So, oh great, I have to. Oh, I have to. That's not right. That's not right. I'm supposed to actually get that from the JSON, not create this myself. So I'm just going to copy another one. Hello. Yes. Okay. Copy NB3 arb weight change to nbdemo. Okay, so I'll go back, go away, and I'll go to nbdemo2. Okay, so this is one with 4 tokens. That's great. We have USDT. Decoding type can be simplified or contract, but contract call, but go with simplified. We want weight changing to false. And now we can generate the initial state from our demo pool. Let's see if this works. We can run all the cells clear, all output clear, then we run all above. Yes, so here we have the initial state of our pool, weight 0.25 because 10 divided by 4 is 0.25. We have our Jesu token, we have our Sushi token, we have our Kirti token. And here we have our token prices, and this is derived. These are our spot prices. So Vasi token is worth this much in Jesu token, and so on and so forth. All right, so let's step through this. Our TX cost, we set it to 30 USD, and all right. External token prices. Yes. Everything looks okay. We really have to really look at everything closely here, because it's not so easy to keep track of where you have to. Okay. Now we do not want arbitrage. We do not want the arbitrage agent. There we go. So now the only driving thing here is the action decoder, which pulls actions from the action.json that we just copied. And then it's going to do this to change all these state variables. Now we're going to set up the CAD params. We have 5119 external price update, so therefore it's going to be 5119. Then we'll run it. Nothing should happen actually, so this should be rather fast. And now we're just waiting. We are waiting. Ah, okay, that's very good. Okay, it finished. It took 44 seconds. And now we go on to this one, and that one, and post-processing. Post-processing basically takes the CAD history, and okay, I knew that would be a problem. Yes, so post-processing here basically transforms the data in the DF to make it graphable, you know, but this kind of needs to be modified with each particular pool somewhat, depending on the questions that you want to answer. So it's best that you create your own branch and modify post-processing here for your own purposes. Yes, so this is our current state of the data frame. We have a data frame, and this is just a copy of the pool state at each time step of the simulation. Then it recorded what happened here that made this state change as a state thing. Then it records the token prices. This is the spot prices. And that's all. Yes. It might have something to do with that. If I do that, well, okay. Yes, so unfortunately I cannot show you any graphs because then I have to replace everything in here with
No, okay.
your tokens. And also there is something rather specific in post-processing that I have to do. But you should be able to know what to do with the data frame just from this point. Yes. Yes, is there anything else you'd guys like to know?
Okay, so that's relatively simple. Set it up. Okay.
I understand that you generate this file in order to create graphics, and that's where you study, no, the results and other things.
No, we do not generate a file to create the graphics. Wait, what graphics? You mean the graphs? The graphs down here?
I mean, the simulation, the output of the simulation is that format, and so you use it. So what are the next steps once you generate this simulation?
I'm sorry. Could you type it out? Like your mic is kind of bad.
Excuse me.
Yes, that is true. Yes, the graphics are quite specific to this. Yes.
Andrew, quick question. So I've heard of single token pools. And how do you create that? Is that on the same basis? Or is it...
We have never created a single token pool. But there shouldn't be any problem to doing that. I mean, you just cut out all that stuff. But then, of course, the problem is the actions.json, because the actions.json would specify a price update for 4 tokens. So you'd kind of have to futz with that, you know?
Okay. So the actions file, it updates all parts of the CAD pre-built model. Does it?
No. The actions file is simply a driving force.
Updating this.
It just says, now the prices of the tokens on an external exchange are this. And now the prices are this. And now the prices are this. And in between those, you could actually have like recorded trades that you pulled from either Scan or BigQuery ETL. The script does that for you, but it's quite finicky to run the script. It only works on balancer pools. It doesn't work on power pool pools, for example. And so that part of the script is a bit creaky. You can write your own actions by studying the other pool, the other pool's actions.json there. And yes.
So that means in order to run a scenario simulation with a scenario, I have to define, or I have this scenario in this JSON actions JSON file.
Yes.
And this can be a file that can be generated from external data,
Yes.
or I can do it by my own. I can say, I don't know, for step 1 this, for step 2 this, and so on. It's
Yeah.
also possible.
Mm-hmm.
Okay.
And what you can, the two things you can specify in the actions.json are external price updates and any trades that happen to the pool.
Okay. So if I want to simulate my pool as a closed system, I don't have to use this JSON file, right?
No, you don't actually have to.
No. Mm-hmm.
One question: when you update the external price, it implies that the arbitrage occurs, or what are the impact of the external price?
So we have here the external price updates coming in from the actions.json, and based on this, we have another policy called the arbitrage agent, and the arbitrage agent looks at this external price situation and it says, should I make a trade or not? Now this trade is not in the actions.json because the actions.json is for, trades that actually happened on the chain. So the arbitrage agent makes a trade by issuing like a policy output to the pool state update function, and yes, that's how it works.
Mm-hmm.
Okay. So one question: if you want, one of the questions of our group was to modify the ponderation of the percent of the pool or the weight. So, is there also another option? Is there an option to change these weights sometimes? But as I understand, if you change the weight, you will generate an arbitrage opportunity.
Yes.
That's correct, no? So, in order to change the price, if you want to read, because one of the questions of our group was how can we manage change in the weight in order to avoid impermanent loss. So, as I understand, the way to simulate is to change weight, not during the simulation.
Well, I can show you what we're doing right now because PowerPool is examining the exact same question.
Yeah. We are in the PowerPool group.
You are? Okay. So let me see. I need to share my... Okay, wait. Where's the other one? So in order to enable weight changing, you need to change this one here to true. Okay? And the way this works is that I decided not to write this part as a CAD policy state update thing because it was getting a bit unwieldy. I figured it would be simpler to write this in a Python way. And the way I did this is, so remember there's a true here. I'm going to stop presenting. I'm going to share another screen. All right. So here we have let's see, where was it now? Pool state updates. pool state updates. So there we saw that I set weight changing to be true. And that will trigger this part. If get params weight changing is true, then it will use this wrapper function, power pool weight change delta, and it will wrap it around the pool operation state update function, which could be join pool, join swap, extern amount in, exit swap, whatever the hell. It wraps the weight changing function around it. And where is this weight changing function? It's right here. This is the weight changing function, and yes. So it performs the state update just like CAD would, but it records the balances before. Then it records the balances after. Then it looks at the change in balances of them, and it calculates a new weight for it appropriately. Of course, you need unit tests for this. So the tests are in tests, test weight changing. So these are the tests for the weight changing thing. Yes.
Okay.
Is this, this is exactly the research question that you're working on, right, Jesus?
Yes. Sorry, yes, I have to do some work in order to compute my environment right now.
Andre, I have a question. If I clone the branch you show us on Discord locally, so can I run the notebooks, or I need to install something special, or because I have the CAD education environment, and I don't know if it's if I need additional modules to run it.
Whenever
Do you have an idea?
you start a Python project, you always need to set up a new virtual environment for it. And whenever you start a new virtual environment, you must install the requirements in the requirements.txt.
Okay.
And these give you, the requirements.txt is the basics you need to run it. It is not everything we use when we actually develop it. So, for instance, here there is no IPDB, but if you just install this requirements.txt and try to run the NB3 notebook, you will find that you will need IPDB because it's very useful. It's a debugger. So, just pip install it. Do you use pip or you use virtual env?
Yes. No. Pip.
Yeah, you
okay, cool.
should use virtual env wrapper. Check it out, virtual env wrapper.
Okay. I will try.
Are you guys mostly using Anaconda or something?
Yes. I'm using Anaconda,
Me too.
so I have to figure it out, and I'm not 100% sure how to do it. But if I have some questions, it's okay if I contact you.
I don't really know much about how to use Anaconda personally. I do it all via the command line.
Okay.
In my experience, like the nice graphical interfaces, they make some things easy, but then they make other things very difficult. So I just stick with the command line.
Cool.
Then you're running all of this in Visual Code, right?
No, I just edit in Visual Code, and for debugging, I use IPDB, and actually mostly I don't even. I try not to debug from Jupyter Notebook anymore. So it is possible to use IPDB within Jupyter Notebook, but I find it's much better to just write a test to exercise that specific code that I want to do, and then I put an IPDB in there whenever I want.
Okay.
How much experience do you guys have in Python programming actually?
Well, I am a beginner in Python. I took the CatCat Beginners Bootcamp, and actually that's it.
Okay.
I develop in Hackmoney, but I have experience in Java and other environments. But I developed in Hackmoney. I installed one environment. I will develop it for 1 month. A project in Python, but I need probably more
Oh,
than a month of environment.
okay. So
I coded
go on.
C, C++ back in the university. That was like now, like Vasilios, I've just started going through the beginners module and completed that. But I'm comfortable because for Hyperledger,
Yes.
as well as I've programmed a little bit in Solidity. Nothing significant, just tried my hand at it. So I'm basically comfortable using, any IDE environment. So.
Okay. Yeah, I worked a bit with Hyperledger as well. So I guess I should probably make this very clear for you guys. In Python, so to avoid dependencies of each program that you write cluttering up the whole system, we basically store dependencies within the folder, just like npm node and all that stuff, and So, but where do you keep these folders? It's kind of like unwieldy. So that's why we had this thing called virtual env wrapper. This one, you need virtual env wrapper. So how this works is that I create a new virtual environment and I call it demo balancer. And this thing will create a new folder here in my home. And then you see I am now within this demo balancer.
Yeah.
And now I install the requirements. And so now, whenever I run the Python within this virtual environment, I will have all of these libraries there. But once I exit this virtual environment, I will not have these libraries available anymore.
Okay. Well, yeah. Very helpful. Yeah.
Yeah.
Any more questions?
No, from my side is okay.
I was going to ask Andrew, can this work with Anaconda then, like the previous CAD? I mean, do you think it would work with Anaconda, like the existing CAD model of Balancer V1? Like you can run. I wouldn't have to migrate from Anaconda, right?
Actually, Anaconda is just doing this in the background.
Okay.
I need, I think, to set my environment, and later probably I can really ask your question. It's very, very helpful. I see all the code and it seems quite straightforward. So, yes, and I think first is to take time to install and be comfortable with my environment. And later I will ask you. What this video, you are going to share this video in the group?
Oh yeah, I suppose I should, huh?
It would be a good idea.
Okay,
Yeah,
I'll
in
put it
order
on
to review
YouTube or
what
something.
you all the information. So thank you very much. I have to leave and develop. Thank you very much. I think, yeah, very, really useful. And I will try to have my setup okay with all the information. Thank you.
Okay.
Okay, Andrew, thank you very much.
Thank you very much, guys. I'll.
Andrew,
Bye bye to everyone. Bye bye.
or sorry, I just have like one last question, if you don't mind.
Yes, Kitty.
Just wanted to kind of touch like very quickly on the analysis bit. So, you know, in while we're doing this CAD simulation, there's this part where it talks about looking at of the outputs, you know, using Plotly. Is that something done here, or you know, just to try and understand how?
Yeah, it's done. I just need to. I mean, it needs to be done for every single pool that you are analyzing.
Right.
So
That's right.
let me show you one that works.
Okay, just as an example, that'd be great.
So if you just open NB3, and if you take the time to wait for the about, I think it's 600 seconds it takes to run to the simulation, NB3 works and will generate all the graphs for you. I promise. I tested this several times. Yes, so I deleted the graphs. Oh, they're there. That's crazy. So these are the graphs. You'll have to edit this all the way. Yeah, the graphs are getting the graphing part of the notebook to work is the most tedious part of the job here. Otherwise, you can just use the code editor stuff. But this one, you just got to go through every graph manually. Yes, if you want to, so look, it's quite important that this thing takes a bit of time to run, right? So that's why this cell is here. You can save the results as a pickle, and then later on when you want to work on the graphing code, you comment this part out, and then you uncomment this line, and then you can just take off from there.
Okay. I'm going to give it a try and see how it works. Well, that's pretty much it. I guess we've covered everything. So we've done configuration, execution, looked at a bit of analysis, how to go about the analysis piece, at least the outline. So it's now for me to go away, set up the environment, and give some of these things a try and come back if I have more questions.
All right then. Good luck, guys.
Okay. Bye-bye to everyone.
Thanks, Andrew, for being a bit patient. This stuff is very basic. I understand. I appreciate your help.
It's okay.
Thank you, Andrew.
Cheers.
Bye-bye.
Thank
Bye.
you.
Thanks so much, Andrew.